There you can see the constructor. There is a variable address data type crypto dev token address, which is set when this contract is deployed. There we are passing the crypto dev token. Here exchange is inheriting ERC20 because our exchange would keep track of crypto dev LP tokens. So here we are inheriting the ERC20 token. Now let's move on. Time to create a function to get reserves of the Ethereum and crypto dev tokens held by contract. The Ethereum reserves would be equal to the balance of the contract and can be found using address this.balance. So let's just create a function only for getting reserves of the crypto dev tokens. We know that the crypto dev token contract that we deployed is an ERC20, so we just call the balance of to check the balance of crypto dev tokens that the contract holds. So let's create a function get reserves. Excuse me. So here we are returning the balance. Now let's move on. Time to create an add liquidity function which would add liquidity in the form of ether and crypto dev tokens to a contract. If crypto dev token reserve is 0, it means that the first time someone is adding crypto dev token and ether to the contract. In this case, we don't have to maintain a ratio between the tokens as we don't have any liquidity. So we accept any amount of tokens that user has sent with the initial call. If crypto dev token reserve is not 0, then we have to make sure that when someone adds a liquidity, it does not impact the price which the market currently has. To ensure this, we maintain a ratio which has to remain constant. The ratio is crypto dev token amount. User can add crypto dev token reserves in the contract equal to ether sent by the user, ether reserves in the contract. So this will be the formula. Crypto dev token user can add divided by crypto dev token reserve in the contract minus ether sent by the user divided by ether reserves in the contract. So this will decide how much crypto dev token user can supply. Given a certain amount of ether when user liquidity, we need to provide him with some LP tokens because we need to keep track of the amount of liquidity he has supplied to the contract. The amount of LP tokens that he get minted to the user are proportional to the Ethereum supplied to the user. In the initial liquidity case, where there is no liquidity, the amount of LP token that would minted to the user is equal to the Ethereum balance of the contract because balance is equal to the Ethereum sent by the user in the add liquidity call. When there is already liquidity in the contract, the amount of LP tokens that get minted is based on a ratio. The ratio is LP token to be sent to the user liquidity divided by total supply of LP token in the contract equal to Ethereum sent by the user divided by Ethereum reserves in the contract. So It seems a bit confusing to you. Open up the previous relation again and review the mathematics behind x y equal to y equal to k price function and LV tokens. You can check out the previous section intro and deep into the live exchange where this is defined more descriptively. Now let's move on and add liquidity function. Let's copy it and paste it here. So let's see the function. Liquidity, here we have added the amount that user will going to send. Then here it is uint local variable liquidity Ethereum balance of this contract, then crypto dev token reserve category reserves ERC crypto dev token equal to ERC crypto dev token reserves. So if the reserves is empty, intake any user supplied value for ether and crypto dev tokens because there is no ratio currently. If there is no reserves, then use this condition, transfer the crypto token from the user account to the contract. Okay. Excuse me. So here we are transferring the amount to the contract and take the current Ethereum balance and limit Ethereum balance amount of the LP token to the user. Liquidity provide is equal to the Ethereum balance because this is the first time user is adding Ethereum to the contract. So whatever Ethereum contract is equal to the one supplied by the user is the current add liquidity call. Liquidity tokens that need to be minted to the user on add liquidity call should always be proportional to the Ethereum specified by the user. So here it is. So here it is. We are minting the liquidity mint ERC20 smart contract function to mint ERC20 tokens. So now let's get a condition if already have a reserves in this contract. The reserve is not empty, intake any user supplied value for the ether determine according to the ratio how many crypto dev tokens need to be supplied to prevent any large price impact because of the additional liquidity. Ether reserve should be the current balance subtracted by the value of the ether sent by the user in the current add liquidity call. Ethereum reserve equal to Ethereum balance minus message dot value. So it will going to minus the current balance of this contract minus the value sent by the user. Ratio should always be maintained so that there are no major price impact when adding liquidity. Ratio here is crypto dev token amount user add divided by crypto debt token reserves in the contract. Okay, here it is. Now there's a condition where is checking this amount of tokens sent is less than the minimum tokens required. So there should be a amount that need to be sent in order to add liquidity. Transfer only crypto token user can add amount crypto debt tokens for user account. Crypto debt transfer message is sent as a token. The amount of LP token that would send to the user should be proportional to the liquidity of ether added by the user. Okay. So here is maintain LP tokens to be sent to the user. Liquidity divided by total supply of LP tokens in the contract. So ether sent by the user divided by ether sent in the contract by the sum at liquidity equal to total supply of LP tokens in contract is the function multiply ether sent by the user divided by the given contract. So that's what the liquidity is, and that will going to mint it. So let's move on to next function.